Okay, we are cruising. Go ahead and put your name on here. It is second hour right now. All right, today in 6.1, this is finding zeros of quadratics part 1, and then 6.2 is part 2. So part 1, part 2, they come right back to back. A quadratic, we already talked about this when we were making our pockets for our notebook. A quadratic is a polynomial with a degree of 2. So if you look down at your examples, they all are x squared. If you look on the back, they're all x squareds. X squareds, x squareds, x squareds. So everything has a degree of 2. The graph of a quadratic is called a parabola. That is spelled P-A-R-A-B-O-L-A. So it's spelled parabola, but it's pronounced parabola. So don't say parabola because people will think you don't know what you're talking about. So in this lesson today, in part 1, we are only going to be finding zeros of quadratic functions that have a leading coefficient of 1. So in this form, ax squared plus bx plus c, a equals 1. So we just won't have a number there. So if you look at our examples, today there's no number in front of x squared ever. Tomorrow, Thursday for you guys. It's currently Tuesday. I keep thinking it's Monday. Tuesday, so it's currently Tuesday. Thursday for you guys, we will add in that number in front of x squared. And it's kind of a more advanced version of the same thing. Okay. Then I have a little diagram here. So a parabola, which is the graph of x squared, is U-shaped. So it can either be U-shaped this way, where it opens up is what they call this, or it can open down. So it can either be like a U or a lowercase n, like a smiley face or a rainbow. A hill. I think what you're thinking of is a hill, not a mountain, because it's not pointed. Okay, so anywho, there are a bunch of little parts and pieces of a quadratic. So by the end of this unit, you guys will be able to find the axis of symmetry, which cuts it in half, the vertex, which is like the top point or bottom point, your y-intercept, and then we'll reflect that one, and our x-intercepts. So you'll be able to find all of that and graph all of that. Today, we are just doing x-intercepts. Right here, zeros are the same thing as x-intercepts as the same things as solutions. So different people, they all mean the same thing. And if you were to say, find the zeros of the function, or find the x-intercepts, or find the solutions, that all means the same thing. That's what we're doing today, okay? Any questions right now? All right, we are looking at 2 methods of finding those zeros today. Method 1 is just solving. So we are just going to solve for x. So to find those zeros, we want the quadratic function to equal 0. So the first thing that we are going to do is set our quadratic equal to 0, and then we just solve like a normal equation. So I'm going to take my pen, I'm going to cross out where it says f of x equals, and I'm going to put equals 0 over here. So I am setting my function equal to 0. Okay, then I am solving this just like a normal equation. So if I'm trying to get x by itself, the first thing I'm going to do is get rid of that minus 16 by adding 16 to both sides. And I get x squared equals, this negative 16 plus 16 cancels out. 0 plus 16 is 16. Okay. Then we're trying to get x by itself. I'm going to white this out. I don't know why my x looks like that. What is keeping x from being by itself? The squared, the exponent. Okay. What is the opposite of squaring something? Square root, yeah. So the opposite of squaring something is square rooting it. So squaring something means multiplying it by itself. Square rooting something means what times itself equals this. So we're going to take the square root of both sides of our equation. So the square root and the square cancel each other. What is the square root of 16? Okay, I agree. If you look up at our little diagrams, all of our parabolas have two x-intercepts. And I have two little blanks here that say zeros, blank and blank, because we're going to have two answers. What other number times itself equals 16? Negative 4. So I'm going to put what's called a plus or minus sign in front of this 4. So it's literally a plus sign on top of a minus sign, which just means this can be both positive or negative. So our zeros, our solutions to this are 4 and negative 4. So we put these blanks on. So here at the beginning of the unit, you can remember I have to have both of my solutions. I have to do my positive and negative. All right, let's do one more, and that way, this is the easier option of today. Maybe, I don't know. So we're going to set it equal to 0. I shouldn't say things are easier, because some people might think the other option's way easier. Okay, we'll add 169 to both sides. We get x squared equals 169. And then to get rid of my square, I need to find the square root. This is a perfect time to remind you where your square root button in your calculator is. It is on top of the x squared button. So it's above x squared. So it's right here. And you have to use the second key. It's like using the shift key on a computer. So you do... Okay, well, my calculator's turning on, and you can't even see the screen. You do second square root, and then it should look like that. Or you can put in 169. What's the square root of 169? Or negative 13. So our answer is plus or minus 13. And then we can separate that out into our zeros. Our zeros are 13 and negative 13. All right, any questions about solving? Okay, there's one more note right here. We were only able to use this method if b equals 0. There's no middle term. So see how I just had x squared and then my c term, x squared and my c term? If I would have had an x in the middle, so like let's say I had x squared plus 2x minus 16, then right here I would have had x squared plus 2x, and we can't take the square root of that. So you can only use this method if there is no middle term. Okay? Any questions about that? All right, flip this over then. The other method for solving quadratics that we are going to look at today is factoring. We can factor and then use the zero product property to find our zeros. The zero product property is if the product of two or more factors is 0. So let's say we have two things, A and B. So if A times B is 0, then at least one of those things, one of those factors must equal 0. So either A has to equal 0 or B has to equal 0. So if we can factor it out and make it a multiplication problem, then we can set each piece of our multiplication problem equal to 0 and find our zeros from there. So that sounds like a lot, but it's literally one super easy step more than what we did in 5.6 and 5.7. So in 5.6, we looked at these trinomials where you had no number in front of x squared, and then you had a b term and a c term. In order to factor these, we would find two numbers that multiply together to be c and add together to be b. So we need to find numbers that multiply together to be 12 here. So put a little note if you need to. Multiply to 12. What are we trying to add to? 7. Okay. For this first one for the day, I made these all positive. What multiplies to 12 and adds to 7? 3 and 4. 3 plus 4 is 7. 3 times 4 is 12. So we are going to have our factored form is going to be x plus 3 times x plus 4. So that is what we did in 5.6 is we factored. From there, we now have to use that zero product property. So if we want this to equal 0, either this has to equal 0 or this has to equal 0. So we're going to split these up into two little baby equations. They're going to be x plus 3 equals 0 and x plus 4 equals 0. And we will solve both of those one-step equations. So x plus 3 equals 0. We'll subtract 3 from both sides, and we will get x equals negative 3. So that is one of my zeros. And for x plus 4 equals 0, we'll subtract 4 from both sides. We get x equals 0 minus 4, which is negative 4. And that's my other 0. Okay. Any questions about either the factoring or the setting each factor equal to 0 part? Okay, we're going to do one more like that then. So we've got x squared minus 3x minus 40. We are trying to multiply together to be that negative 40. We're trying to add together to be negative 3. So if you need to write your factors like we did in 5.6, you are more than welcome to. So my factors are 1 and 40, 2 and 20, 3 does not work, 4 and 10, 5 and 8, 6 doesn't work, 7 doesn't work. And I just moved my paper. Okay, we need to multiply to be a negative. We also want to add to be a negative. So we want 1 to be negative, and we want our bigger ones to be negative. Which ones of these are 3 apart? Yeah. So when I know 1 needs to be negative, instead of thinking which ones add together, I say which ones are that many apart. So if we do 5 and 8, and we leave the 5 positive and make the 8 negative, then that works out. So we've got x plus 5 and x minus 8. Draw a line here to separate that. So that is my factored form. If you want to show yourself setting it equal to 0, you can, because setting it equal to 0 is technically how we find the zeros of it. Right. So then once we get it factored, we do each little factor equal to 0. So we've got x plus 5 equals 0, or x minus 8 equals 0. X plus 5 equals 0. We'll subtract 5 from both sides. What does x equal? Negative 5. So 0 minus 5 is negative 5. For x minus 8 equals 0, in order to solve for x, we'll have to add 8 to both sides. So we'll get x equals 0 plus 8, so positive 8. That's going to be my other 0. Or x-intercept, or solution, or whatever you want to call it. I wrote zeros on my blanks because that's the shortest of those. Alright, I want to take a moment to show you guys. You don't have to write all of this if you don't need to. We are solving by factoring. So you do have to have your factored form. You do need to write down this and this. You don't need to do all of this work. If you can see that x plus 3 means that my 0 is negative 3, x plus 4 means that my 0 is negative 4, you don't need to do all the work in between. X plus 5 means I'm going to have a 0 of negative 5. X minus 8 means I have a 0 of positive 8. So what I highlighted would be the bare minimum amount of work you need to show. You've got to factor it, and you've got to have your zeros. But if you're messing up your positives and negatives again and again, we might have you add in this piece, okay? A lot of people choose to, just so they can understand what's happening, they choose to write down this and this, but then they don't show their work to solve it. So that's what I do, is I put down the factored form, I set them equal to 0, and then I just solve them in my head. Okay, any questions right now? Okay, we've got 2 more problems. These don't have that middle term. So, and they're perfect squares. So 25 is a perfect square, 169 is a perfect square. So we are able to solve these or factor these using difference of squares. Technically, typo alert, if there's an open parentheses there should have been another closed parentheses there. There should have been a double parentheses. Okay, so if I want to factor this, x squared minus 25, so anything squared minus anything squared, difference of 2 perfect squares, I find what the square roots are, and I do a plus b and a minus b. So my factored form of this one, what's the square root of 25? 5. So it's going to be x plus 5 times x minus 5. And that's it. Okay. For this one, I'm going to set them each equal to 0. So the whole thing equal to 0. So x plus 5 equals 0. If I were to solve that, what would I get as my x? Negative 5. And I've got x minus 5 equals 0. If I were to solve that, I would get positive 5. I'm going to skip over showing that extra piece of work. Hey. Next one, we've got f of x equals x squared minus 169. I don't know why I started crossing that off. Actually, I do know, and it's because I was trying to do the wrong method. We're going to factor this. So, what number times itself equals 169? 13. So I've got x plus 13 and x minus 13. Set that equal to 0. Then I set each of my factors equal to 0. So x plus 13 equals 0, and x minus 13 equals 0. If I were to solve this one, I would subtract 13 from both sides, so I would get negative 13 as a 0. This one, I would add 13 to both sides. I would get positive 13 as a 0. Okay, pause. We need to talk about something before you all just start ignoring me and gluing in your notes, okay? This problem right here. Did we already do this problem? Okay, where have we done this problem before? On the front. So these problems here, you can factor using difference of squares and find your zeros that way. Or you can solve them. See how I got the exact same thing? So when I don't have that middle term, I can solve it like this. Or I can do difference of squares, factor it, and solve it like this. So whichever one you prefer when it lets you pick, you may do. Your assignment makes you solve the first two, makes you factor the next four. So just like on notes, solve a couple, factor four. On the back side, you get to pick whether you want to solve or factor. You can factor all of them. You cannot solve all of them. So you will have to factor at least some. Any questions regarding that? Okay, I'm going to stop this video. Bye, video.